Hello, this is the study guide for our probability common formative assessment. Let's talk about number one here. A laundry basket has 24 t-shirts in it. 4 are navy, 12 are red, and the remaining are white. What's the probability of randomly selecting a red shirt? Well, let's see. How many are red? 12. So 12 out of the 24. That's That's one half. You could say one half, or you can say 50%. Usually those are the two that we're looking for there. Okay, what's the probability of not selecting a white shirt? Well, how many are white? If 4 are navy and 12 are red, and the remaining are white, well, that means 16 are here. There are a total of 24. And so that means that we get 16 out of the 24 are not white. So we can simplify that to 2/3. Or you can have it that as 66.6 repeating percent. I would take any of that. Box this one too. Okay, what's the probability of selecting a green shirt? There are no green shirts. So that's 0%. Or 0 out of 24. Okay, and I will box that bad boy too. Okay, next, at a school assembly, 4 out of the first 10 students were wearing spirit wear. Based on the information, if 500 students were at the assembly, then how many students would be expected to be wearing spirit wear? Well, four out of the 10, it said, were wearing the spirit wear. So how many X out of 500 would we expect to be wearing spirit wear? Well, to solve this, we would cross multiply 4 times 500. Oops. And divide by the other number, 10. So that's 20,000. 20 with 2 zeros. Oh, not 20,000. 2,000 divided by 10, which is 200. Done. That's great. And then we have Joy can choose to ride the bus, subway, or take a taxi. What are the possible outcomes? Monday and Tuesday. Let's see. She can choose the bus, the subway, or the taxi. What are the possible? Oh, so this would be Monday. And then Tuesday, she could take the bus. And then on Tuesday, she could choose the bus, or she could choose the subway or the taxi. She could have chosen the subway first, and then on Tuesday, she choose the bus, the subway, or the taxi. And for the Monday, she could have chosen the taxi and then the bus on Tuesday, the subway Tuesday, or the taxi again on Tuesday. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 outcomes. Boom. Number 5. Number 6. A fair coin is tossed 4 times. Sketch a tree diagram for the sample space. What is the probability of getting 4 tails in a row? So I'm going to zoom in here, and on toss number 1, we could get heads or we could get tails. On toss number 2, we can get heads again, or we could get tails, and this is all toss number 2. And on tails, we could get heads on the second time on the second toss, or tails on the second toss. And then on toss number 3, we could get heads, then tails. We could get heads here, then tails. We could get heads here, then tails, and we could get heads here and tails. On the fourth toss, we could get, once again, heads, tails, heads, tails. Oh my goodness. Heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, heads, tails. So, let's see. Back to, so that's all that's the sample space, the outcomes, all the possible outcomes. 4 tails in a row. Well, where do we have 4 tails in a row? We only have 4 tails in a row right here. 1, 2, 3, 4 tails in a row. How many times did this happen? Well, it happened one time out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, 4 tails in a row happens 1 out of 16 times. Okay, so there's that. And then what's the probability of getting two heads in a row? Well, how many times did 2 heads happen in a row? I'll count them in blue. Well, it happened right here. So that's one time it happened. It happened right here. That's the second time it happened. It happened right here. That could be a third time. 2 heads in a row. Well, ooh, I see 2 heads in a row right here. That's number 4. 2 heads in a row. 2 heads in a row would happen here. That's 5. 2 heads in a row here. That's 6. 2 heads in a row here. Here's 7. I think that's it. So 2 heads in a row would be 7 times out of how many total opportunities are there? Well, how many times was it flipped? You know, here's 1. Every time we see a bar, right? There's 1, there's 2, there's 3. Here's 4, here's 5, here's 6, here's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. There's 28. 7 out of 28. And that simplifies to 1/4, or 25% of the time you would have 2 heads in a row. These are the 2 answers for probably the hardest question on the whole quiz. Okay, then we have, oh, that was number 6. Each spinner below will be spun 1 time. If the player wins, the second spinner lands on, okay, what? The player wins if the second spinner lands on A. What's the probability the player will win? Well, what's the sample space? We could land on, we can get 1, then A, we can get 1, then B, we can get 1, then C, we can get 1, then D. Okay, we can get 2, then A, 2, then B, 2, then C, 2, then D. There are 8 different items in the sample space. How many of them happen for A? It's 2 times in 8. It's 1 in 4, or 25% of the time. Okay, there are 4 jacks in a standard deck of 52 playing cards. If Patricia selects a card at random, what's the probability that it will be a jack? Well, it's 4 out of the 52. Divide them both by 2. That's 2 out of, 26, which is 1 out of 13. It's 1 in 13. There you go. Easy peasy. Morgan saw 10 blue, 8 red, 42 white cars drive by her house in 1 hour. What's her experimental probability the next car will not be a white car? Well, how many drove through? Oh, it's just going to be 18. Well, let's see. How many drove through? So 10 plus 8 plus 42. That's 18 plus 42. That's 60. Yeah, it's 60. So it will not be a car, not white, not white car is what is 10 plus 8, which is 18. So it would be 18 out of 60, which take half of those is 9 out of 30. I would say 9 and 30 is the experimental probability that it will not be a white car. Number 10. Philip has a box of crayons. 45 are yellow, 25 are 12 are green, 25 are blue, and there's 7 are red. If Philip selects a crayon at random, what crayon would it be? Okay, what would it likely be? Likely be yellow. It it would likely be yellow because there's more yellow than there is anything else. Yeah. Okay. There you go. Oh. Oh, I I missed this. Which color would he most likely select? It would likely be yellow. What probability will he? What is the probability that he will select that crayon? Well, it'd be 45. 45 yellow out of what? 45 plus 12 plus 25 plus 7, right? 45 and 25 is 70. And 12 plus 7 is 19. So that would be 89. So it would be 45 out of 89. That would be it right there. That's 10. Oops. Number 11. Ooh, a little bit of box and whisker plot here. Which set has more variability? It's tight. 36 to 22, 34 to 20. They're equal. They have equal. They're and I'm looking at from here to here is about the same as here to here. It's pretty much the same. So they don't vary. Oh, wait a minute. No. B has more variability. Set B has more. Because you can see here, the box here is bigger than the other box. So as it's spread out more, as the numbers spread out more, they make the box out bigger. Variability means that you have a larger variability of numbers. It's there's a larger variety of different numbers. Variability, variety, So we have a larger variety of numbers that are spread out, and that happens over B more than it does in A. And this box shows you that it's more. Which has a higher maximum? That would be set B. Because right here we can see that is the maximum number compared to that maximum number. So set B. Set B. What has a greater interquartile range? Set B. The interquartile range is how big is the box? The size of this box is smaller than the size of this box. You can just visually see it right there. The interquartile range is the upper quartile, which is this number, minus the lower quartile. So that minus that is going to be a larger number than this number minus this number. Number 12. Sammy's deciding what to wear to a party. She has 3 shirts to choose from. these here. She has 4 bottoms to choose from. She has 2 pairs of shoes to choose from. How many outfits can she make? Well, tree diagram for this. 3 shirts. So red, white, green. She has 4 bottoms to choose from. Oh my God. I'm going to call it 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oh my God, I'm going to run out of room here. And then she has 2 pairs of shoes for each of those. So I got to go in and call it 1, 2, 1, 2 pairs of shoes, 1, 2 pairs of shoes, 1, 2, 1, 2. She got 2 pairs of shoes for each of these. 2 pairs of shoes. 1, 2, 1, 2. 1, 2, 1, 2, 1, 2. 1, 2, 1, 2. So, how many outfits does she have? Well, you can count down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. The answer is 24. That's how many different outfits she can make. Or you can just do this. You can say, hey, she's got 3 shirts, 3 times, she's got 4 bottoms, 4 bottoms, times 2 pairs, 2. So 3 times 4 is 12, times 2 is 24, which is exactly what I said earlier. And this, I believe, that concludes what we need to know for this. Thanks for watching.